Okay, make sure you have your notes printed before you watch this video so that you can follow along just like we would if we were in class. If you haven't done that yet, pause this video and go grab those and then come back. Okay, this is investigation 3, exploring angles of polygons. So notice you'll have interior angles, which are on the inside of the polygon, and you'll have exterior angles, which are on the outside of the polygon. We have these formulas here that I'd like you to copy into your formulas chart. You'll notice over here in the formulas, they're down here at the bottom, and I've included a link for you to copy those when you have time. Okay, so the first one is the sum of the interior angles. Just like the angles in a triangle add up to 180, there are other polygons that have specific sum of the interior angles. And the way you find that is you use this formula right here where n stands for the number of sides, okay? So just like I was saying about a triangle has 3 sides. So if I were to put a 3 in for n, it would be 3 minus 2 is 1, and 1 times 180 is 180. So the sum of the triangle's angles is 180. Now, what if I just wanted to find one angle, not the sum of them added together, but just one of them? Well, then I would use this formula right here. Notice how the numerator looks exactly like this formula, but then one extra step is involved, which is dividing by the number of sides. Okay? So, in other words, using our triangle example again, if I took 3 minus 2, I get 1. 1 times 180 is 180. 180 divided by 3 sides of a triangle is 60. That means a regular triangle would have 60 degrees plus 60 degrees plus 60 degrees, which is the 180. So although their sum is 180, each individual angle is 60. All right, this is the formula you're going to use when you're trying to find an exterior angle or even a central angle. So this right here. And then you would take the 360, you would divide by the number of sides. So say we're using our triangle example again, we would divide by 3, and we would see that each exterior angle of a triangle would be 120, because 360 divided by 3 is 120. Okay, let's practice some of these. I'm going to do one, and then you're going to do one. Okay? All right, so it says, find the interior angle sum of a regular, and I'm going to do hexagon. Okay, now the sum is this one right here. So we know a hexagon has 6 sides. So we're going to do 6 minus 2 times 180 degrees. 6 minus 2 is 4, and 4 times 180 degrees, punch that in my calculator, it's 720 degrees. So that's the sum of a hexagon's angles. Do you remember how many sides a dodecagon has? It has 12 sides. So pause the video and find the sum by using the formula, and then unpause to check your work. Okay, so we plug in the number of sides, which is 12, into the equation, the formula. 12 minus 2 times 180 degrees. 12 minus 2 is 10 times 180 degrees is 1800 degrees. So a dodecagon's sum of all the interior angles is 1800 degrees. Okay, now we're moving on to the interior angle measure of a regular decagon, which is 10, and pentagon, which is 5. This time they don't want the sum, they want one angle. So like I said, this is 10 sides. And the one extra step in finding one angle's measure is to then divide by the number of sides once you've found the sum. Okay, so we have here 10 minus 2 times 180 degrees over the number of sides, which is 10. And when we plug that in, we get 144 degrees each. So each of the interior angles measures 144 degrees. Now, a pentagon has 5 sides, so I'd like you to use the formula and solve for each angle measure inside of a pentagon. Okay, you should have taken 5 minus 2 times 180 divided by 5, and that gives you 108 degrees for each angle in a pentagon. Moving on to exterior angle measures. This is what they want us to find for a regular octagon and triangle. Octagon has 8. We all know a triangle has 3. The formula requires us to divide 360 degrees by 8, which is 45 degrees. Pause the video and try solving for the exterior angle measure of a regular triangle, and then unpause to check your work. Okay, 360 degrees divided by 3 sides equals 120 degrees for each exterior angle. And then remember, when we're solving for central angle, it's the exact same formula as exterior. A nonagon, if you remember, has 9. A heptagon has 7. So 360 divided by 9 is 40 degrees. Pause and try solving for the central angle of a heptagon. Once again, we take 360 divided by 7, and we get 51.43 degrees. Okay, that is investigation 3. We are now going to move on to lesson 31, which is flow charts and paragraph proofs. They are super simple. They are much easier than 2-column proofs, in my opinion. You'll notice that it's called a flow chart because of the way it flows from one section to another. Now, inside of each of these boxes, we have the statements. So these will all go in this section. And then beneath each box, we have the reasons. And each of these will go in the reasons column. So it's basically just copying what we see. So we're going to start with this one right here and list it as given in the first. So you go top to right, to left to right, from bottom to top. Okay. So in this first one, we're going to write angle 1 is congruent to angle 3 because it was given. And then, so we took care of this one right here. Now we're on to this one. We're going to say angle 1 and angle 2 are supplementary, and once again given. Angle 1 and angle 2, and I'm going to abbreviate, are supplementary. Once again, that was given. So we took care of that one. Now we're over here. Measure of angle 1 equals measure of angle 3. Definition of congruent angles. Measure of angle 1 equal to measure of angle 3. Definition of congruent angles. Okay, took care of that. Now we're on to this one. Measure of angle 1 plus measure of angle 2 equals 180 degrees. Definition of supplementary angles. So, measure of angle 1 plus measure of angle 2 is equal to 180 degrees. Definition of supplementary. Once again, I'm going to abbreviate. Okay, we got that one. So not hard, maybe a little tedious, but not hard. This is the next one. Measure of angle 3 plus measure of angle 2 equals 180 degrees. Substitution property of equality. So measure of angle 3 plus measure of angle 2 equals 180 degrees. Substitution POE, property of equality. Okay, last one. Angle 3 and angle 2 are supplementary. Definition of supplementary angles. Angle 3 and angle 2 are supplementary. Definition of supplementary angles. Okay, pretty cut and dry. Now I want you to try one on your own. So pause the video. Make sure you put all of these from top to bottom, left to right, inside of the statements column. And then all of these reasons that are at the bottom of each box go inside the reasons column. So pause the video, copy that, and then come back. Okay, we have angle 1 and angle 2 complementary. That was given to us. Another thing that was given to us is that angle 1 is congruent to angle 3. Then it said that measure of angle 1 plus measure of angle 2 equals 90 degrees. Definition of complementary angles. Measure of angle 1 equals measure of angle 3. Definition of congruent angles. Measure of angle 3 plus measure of angle 2 equals 90 degrees. Substitution, POE, property of equality. And then lastly, angle 3 and angle 2 are complementary. Definition of complementary angles. How'd you do? Pretty easy, right? Okay, last lesson of the day. We have here lesson 32, altitudes and medians of triangles. Now, first with some definitions. What is a median of a triangle? It's a segment whose endpoints are the vertex of a triangle and the midpoint of the opposite side. There is one median for each vertex. One median for each vertex. So take a look over here in this diagram. These are each called medians. Do you notice how they go from the vertex to the midpoint of the opposite side? See how C is the midpoint of LM? And then from the vertex of M to the midpoint of the opposite side, LN. From the vertex of L to the midpoint of NM. So those are called medians of the triangle. Okay, now this is what it meant. So there's one median for each vertex, which means there's 3 medians total in a triangle. What we're going to focus on today is finding the centroid of a triangle It's the center of gravity. And it's the point of concurrency of the three medians of a triangle. Essentially, it's where the three medians cross. So back here at our diagram, this right here would be the centroid of that triangle. See right here, this diagram? This is the centroid of where all three medians cross, where they intersect. Okay, you'll want to copy this into your theorems chart later. The centroid of a triangle is located 2/3 the distance from each vertex to the midpoint of the opposite side. So take a look at this diagram. What they're saying is that CP, let me find it, right here, CP is 2/3 of the entire line, which is CZ. So how CP is 2/3 of CZ. Makes sense, right? Because this is, if I were to divide this into 3 equal sections, this one's 2 out of the 3. So this is always 2/3 of the entire line. And they just keep repeating themselves with all three medians. So see this? BP is 2/3 of BY. So BP is 2/3 of the whole thing. And then lastly, AP is 2/3 of AX. So see this? AP is 2/3 of the entire AX. Okay? So they're basically the same equation. All right, so what would a homework question look like? This right here says to find LO and NC, given that in triangle LMN, LA is 12 and OC is 3.1. So we are going to use this to find this, and then this to find this. Okay, so let's start with the green. It says that LA is 12, so let me find it. LA is the whole thing, okay? They want us to find LO, so that's this. Well, if we start by writing down that LO is 2/3 of the whole thing, we can then substitute 12 in for LA, right? We can write 2/3 of 12. Well, this is beautiful because I can cross reduce that, make it a 4. And 2 times 4 is 8. So LO is 8. All right, now let's use OC to find NC. Well, OC is right here. They gave me the 1/3 instead of the 2/3. So I'm going to write this differently. I'm going to say that OC is 1/3 of the whole thing, right? Because they didn't give me the long side, they gave me the short side. And now I can substitute 3.1 in for OC. And notice how it says divide by 3, right? So I can times by 3 on both sides, so that cancels. Times 3 over here. And then we find that NC is equal to 9.3. Okay. This is a more challenging problem, but we're going to do it together so that you feel comfortable. It says find the centroid of triangle DEF. So DEF. So this triangle right here. Vertices at D, -3, 5, E, -2, 1, and F, -7, 3. Now remember what I told you. It goes from the vertex to the midpoint. Vertex to the midpoint. Vertex to the midpoint. Now, essentially, if we can find where these two cross, then we've already found the centroid. So there's no sense in doing the third one as well. If you have 2 out of the 3, you're already set. So what we're going to do is we're going to start by finding the equation of the line. Do y'all remember y equals mx plus b? So we are going to take E right here and find the equation of this line. So let me mark that with red so that I can color code this and hopefully you'll see. So E, they said, was at negative 2, 1. Negative 2, comma 1, right? And then we can see this, so that was negative 2, 1. We need to find this point right here, which looks like it is at negative 5, 4. Do y'all see that? This is at negative 5, 4. So I'm going to write that down, negative 5, comma 4, and I should probably write it here too, so you can look back at your notes and tell where this came from. And then this was negative 2, 1. Okay, so remember, we have x1, y1, x2, y2. Slope formula says to take y2 minus y1 over x2 minus x1. So 4 minus 1 is 3, plus plus, that's a negative 3. 3 divided by negative 3 is a negative 1. So that's just our m. We need to find our b. Okay, so we have our m in the y equals mx plus b. We're going to use a y and an x, which I'm going to pick this one. You could have picked this one. Either one will work. So, let's see what's going on here. Hold on one second. Okay. So, I'm going to use this one right here. Y equals mx plus b. So we have 1 equals a positive 2 plus b. Subtract 2 from both sides. We get b is also negative 1. So we have b negative 1. We have m negative 1. And so when we plug it into y equals mx plus b, we get y equals negative 1x minus 1. Okay, so we're going to save that for later. We still have to do this one over here, which I'll do in blue. So we have f over here to its midpoint. Now f, we know, is negative 7, 3 from what the word problem told me. And for this midpoint over here, we can look down and tell that it is at negative 2.5, comma 3. So let me write that down. Negative 2.5, comma 3. All right. So we have negative 7, 3 and negative 2.5, comma 3. All right, same thing. We're going to do x1, y1, x2, y2, and we know that the slope is equal to 3 minus 3 over negative 2.5 minus negative 7. And I want to stop us right here because the minute you see that the top's going to be 0, you know that the m is 0. You don't have to even do the denominator, right? Because when the top is 0, the full answer is 0. All right, so now time to find our b, which I'm going to use this one right here. You can use either one you want. Y equals mx plus b. Anything times 0 is 0, so 3 equals b. So now I'm going to plug my m and my b back into the y equals mx plus b, and I get y equals 0x plus 3, which means y equals 3 since there's 0 x's. Okay, so that's the equation of that line. Now, final step. I have to find where these two intersect, right? Because I'm looking for this right here. Now, I can use substitution because that'll work beautifully. You see how y equals 3? I can put the 3 right there. So I'm going to do that in purple. I'm going to say 3 equals negative 1x minus 1. Add the 1 to the other side to get 4 equals negative 1x. If I divide by a negative 1, I get x equals negative 4. So, time to write my answer. as an ordered pair. So I'll do that in orange. My final answer is a -4 for my x and a 3 for my y. That is the point at which the two medians intersect. I know that was a lot.